Alright, so if we're going to consider this question, the limit as x approaches 2 applied to this rational function 4 over x minus 2, does it exist? Then we have to look at two things. We have to explore what happens when we take the limit as x approaches 2 from the left as it is applied to this function. We also have to take the limit as x approaches 2 from the right as it is applied to this function. We've got to explore the left hand and the right hand limits, and we have to see if we get the same things back for both. If these values are the same, then the answer to that question is yes. This limit exists. In fact, that limit equals these two values. But if those two values are different, then to answer this question, we say no. Since we're just getting introduced to this idea, we're going to do a lot here with just exploring the graphs. For this rational function, let's type that one in the calculator. Let's take a look at the graph and see what happens from the left and the right of 2. So go to y equals, clear that out. I'm taking, let's see, 4 divided by a quantity, so I got to use parentheses here, x minus 2. Be careful how you type that in. If you graph this out, now depending on the brand of calculator, that line that cuts through 2 there may or may not be there, but understand that line is an asymptote. It should make some kind of sense because x cannot be 2 here, right? If x was 2, this function would be undefined. But if we look at this function, and we hop on this function and travel in from the left of 2. So here's where x is 2. To the left of 2, the only part of this function that's defined would be this part over here. As I'm traveling in from the left, notice what's happening to the function. The function's going downwards. Since the function is going downward, it's actually not approaching any set point. It's actually going to negative infinity. So from the left, I would say the limit as x approaches 2 from the left of this function is equal to negative infinity. Now from the right, as long as we got the graph up here, again, here's where x is 2. From the right, the only part of the function we have to play with is this guy. Traveling in from the right, notice how the graph, as we get closer to 2 from the right, is going up. Once again, not going to a set point. So since it's going up, we would say the limit as x approaches 2 from the right of this function is equal to positive infinity. So let me go back, fill this in. This is negative infinity. This is positive infinity. But more importantly, these two ideas are not the same, right? So does the limit as x approaches 2 apply to this rational function exist? No, it does not. All right, so back here on number 2, if we look at the first 3 parts and we walk through these together, we're basically exploring what's happening with this function as x is getting closer to 4. So if I go to the graph here, starting with x approaching 4 from the right. Okay, on this graph, let's go to that proximity where x is 4 on the graph. Notice where x is 4 on this graph, we've got several things going on, right, in this location. So if we are traveling in from the right of 4, that would put us on this piece of the graph. As we travel and we get closer and closer and closer, sufficiently close, but not actually to the point. The point we're getting closer to would be this guy, right? I know it doesn't exist for the function, but we're getting sufficiently close to it. So assuming that point's there, should we arrive at that point, what's the value of the function at that point? 6. Okay, it's 6. So this would be 6. Traveling in now from the left. Let's see, here's 4 again, that proximity, right? traveling in from the left. Left of 4 is going to be over here on this piece. If I travel in and get sufficiently close to where x is going to be 4, that's going to be this location right here, right? Once again, I know as far as the function is concerned, that value doesn't exist, but I'm getting closer to that point. I'm assuming it would exist if I got there. What's the value of the function? 2. So limit as x approaches 4 from the left, apply to this function, 2. Now in order to answer the limit as x approaches just 4, as it's applied to this function, we have to have already explored from the right and from the left. And we take the work that we've already done up there and we summarize our answer here for C. Since these two values don't match up, then for C, this limit would not exist. Now, had those two matched up, whatever that answer would have been, say this one was 5 and this one was 5, then answer down here would be 5. So we got the 3 more parts. Now we're playing with the proximity of where x is -5, right? So let's go back to the graph. For this first one, we're taking the limit as x approaches -5 from the right. So -5 is right over here. We're traveling in from the right of that point. Only piece of the graph we can travel on is that guy, right? So there is a path to travel on. It's getting closer to this point. At that point, the y value, which is the value of the function, would be 0. Now, as we approach x, the -5 here from the left. Oops. Go back to the graph here. All right, to the left of 5. To the left of 5 is out here. Do you see any piece of the function to travel on? No. So no road exists, right? There's no path to travel on. I go the right direction here. Where was I going? There we go. The limit as x approaches -5 from the left would not exist since we don't have a road to travel on. Meaning, the limit as x approaches -5 in general, where you have to consider both the right and the left and see what those values are, this would not exist because the answers we got for D and E didn't match. All right, so yeah, say we had to find f of 4. What this means is give me the value of the function where x is 4. So you go on the graph to the exact point where x is 4. So where x is 4 right here. Right, it's defined right here. What's the value of the function at that point? It's the y value. So it would be just 4. As long as we're at it, you want to do the next one? I don't mind. Next one's f of -5. So f of -5, again, this means what's the value of the function when x is -5? You go to the exact point on the graph where x is -5. That'd be right here. Y value associated with that point, which would be the value of the function, would be 0. Mm-hmm.